Good morning, one and all. Today I am discussing about Applied Geotechnical Engineering 18 CV 62 Module 4 Lecture Series 8 for 6 semester students. Today we are discussing about plate load test by determining bearing capacity of the soil. Plate load test is a field test to determine the ultimate bearing capacity of the soil and the probable settlement under a given loading. The test essentially consisted in loading a rigid plate at a foundation level and determining the settlement corresponding to each load increment. The ultimate bearing capacity is then taken as the load at which the plate starts sinking at a rapid rate. So loading according to IS 1888 1962 guidelines only. So let us consider the construction of plate load test procedure. Excavate a pit whose depth is equal to depth of the foundation, width is equal to 5 times the width of the plate which we are using. There are two types of plates we can use it: 30 cm by 30 cm by 25 2.5 cm thickness plate, or 75 cm by 75 cm by 2.5 cm plate. Generally 30 cm by 30 cm plate we are using for conduction of the test. 5 times the 30, that is 1.5 meter width will be the size of the pit we have to excavate. At the center we have to excavate another depth dp. dp is equal to dp by bp is equal to df by bf, or dp is equal to df by bf into bp depth, and we have to excavate the size is equal to the width of the plate. Step number 2, if at all any groundwater is encountered, remove that groundwater by using suitable dewatering technique. Next step is fix the plate at the center. Over the plate a hydraulic jock will be placed which is connected to a proving ring. That proving ring in turn connected to the reaction frame. Two types of reaction frames are used in practice. One is a truss type of reaction frame, another one is a sand loading back type of reaction frame. In foreign countries, truss type of reaction assembly is used, whereas in India loading sandbags will be used. Next, 3 dial gauges has to be fixed with a sensitivity of 0.02 mm on the top of the plate as shown in the figure. Next, so apply a 70 gram per centimeter square as seating pressure and see the dial gauge reading value. If all the 3 readings shows a constant value, then declare as 100% seated. Then we have to start the test. Apply 1/5 of the ultimate bearing capacity of the load or 1/10 of the ultimate bearing capacity of load at a time by using hydraulic jack, and record that applied load by using proving ring. Record the 3 dial gauge readings as deformation and increase the that is proving ring readings applied load, and each incremental load record the dial gauge reading. And once the 3 dial gauge reading is obtained, average of 3 dial gauge reading we have to consider. Then we have to plot a load intensity versus settlement graph. Depending on the type of the soil, we may get a graph like this. So for loose shear failure, for loose soil, load intensity is directly proportional to settlement. Or we may get a parabolic type of curve like dense cohesionless soil, where we have to draw a tangent from 2 extremity ends, intersection of tangent to draw a vertical line. That value will give load intensity. Third one is, so when a curve is inclined, so wherever there is straight line portion is there, extend that one in the vertically upward direction, so then you will get the QF, that is dense sand. Failure is a general shear failure. Likewise, we have to calculate the appropriate QF value. If it is a linear variation like a loose soil or a loose shear or a local shear failure, 20 mm settlement we have to record it. Corresponding to 20 mm settlement we have to take the load intensity value. Next, safe bearing capacity is given by QS is equal to QF obtained from the graph divided by factor of safety. You can take factor of safety 2 to 2.5. So that will give in terms of kilonewton per meter square. Next, the effect of size of plate on the settlement. So now what we are doing is we are conducting plate load test by using 0.3 by 0.3 size footing plate or 0.75 by 0.75 plate. but the actual foundation will not be 0.3 or 0.75 meter, it is minimum 1 meter. So now the settlement of the plate is different, settlement of the footing is different, and the variation is very high in case of corrosionless soil like sand. So in order to calculate actual settlement of the foundation, we have to use this formula. SF is equal to SP into BF into BP plus 0.3 divided by BP into BF plus 0.3 whole square. Whereas in case of cohesive soil or clay soil, SF is equal to SP into BF divided by BP. Next, there are some limitations of plate load test. Now, first limitation is plate load test is a very good test for homogeneous soil, at least to a depth which is equal to the actual size of the footing isobar. If you have a that is a multi-layer soil, even though if you have conducted a plate load test for 0.3 or 0.75, isobar 0.1 times Q if you plotted, it may falls in a dense zone. That means we may assume that soil is very good, but actual footing when we started constructing in that ground, so 0.1 times the BF actual size of the footing if you calculate, the isobar may fall in a loose soil which is immediately below dense soil. So there will be an error in the estimation will take place. So that leads to failure. So therefore, if it is a heterogeneous soil, first limitation of plate load test is plate load test is not at all a recommended test for heterogeneous soil, and it is a recommended test for a homogeneous soil at least to a depth which is equal to the significant depth of actual footing, not the plate, actual footing. That is first one. Second one, since the load test is of small duration, consolidation settlement cannot be predicted. So that settlement will give only immediate settlement, consolidation settlement cannot be predicted. But for clay soil, consolidation settlement play a dominating role, and which is a time dependent phenomena. It will not take place immediately. So therefore, that is for pure clay soil. So this test is with respect to settlement is not a recommended one. For clay soil, ultimate bearing capacity of large footing is almost equal to that of the plate. For sandy soil, ultimate bearing capacity of large footing is equal to QF is equal to QP into BF by BP. That ratio we have to use it. So now consider a problem. A 30 centimeter square bearing plate settles by 8 mm in a plate load test on a cohesionless soil. So on a cohesionless soil, when the intensity of loading is 180 kN per meter square, estimate the settlement of a shallow foundation of 1.6 meters square and has the same intensity of loading. So BP is equal to 30 centimeter, that is 0.3 meter. SP settlement of plate is 8 mm, cohesionless soil. Q is 180 kN. SF we have to calculate. BF is equal to 1.6. So now we have a formula to calculate settlement of footing. SF is equal to SP into BF divided by BP into BP plus 0.3 divided by BF plus 0.3 whole square. If you substitute in this one, width of the footing and width of the plate, we will get a value that is 22.69 mm. That is the actual settlement of the footing. Even though the settlement of plate is 8 mm, actual settlement of footing because of cohesionless soil it will be 22.69 mm. So if it is less than 25 mm, yes, it is permissible. If it is more than 25 mm, then we have to do some ground increment technique. So coming to the multiple choice question, plate load test is a field test to determine the ultimate bearing capacity of soil and the probable settlement under a given loading. So option A is true, option B is false. Option A, it is true, is the correct answer. Plate load test is conducted as per IS 1888 1962 guidelines. Option A is true, option B is false, option A is true. So SPC QS is equal to QF by factor of safety in kN per meter square for plate load test. Option A is true, option B is false. Correct answer is option A. Factor of safety for plate load test is 2 to 2.5. Option A is true, option B is false. Correct answer is A. Plate load test is considered as IS 1588 1962 guidelines. Option B false. Plate load test is conducted as per ISC 1688-1962 guidelines. Option B false. Plate load test is conducted as per IS 1788-1862 guidelines. Option B false. Plate load test is conducted as per IS 1988-1962 guidelines. Option B false. Plate load test is conducted as per IS 2008-1962 guidelines. Option B is false. Plate load test is conducted as per IS 2008-1972 guidelines. Option B, which is false. So these are the list of the references we are used to prepare this particular module. So I take this opportunity to thank Department of Collegiate and Technical Education officers and students for giving me an opportunity to deliver this lecture. Students, go to LMS portal and understand the today's discussed topic. If you have any doubt, you feel free to ask. Thank you for attending the class.